Okay, thank you. First, I would like to apologize that I did not come to Sweden, but I would really love to. But tomorrow is a very important day for my youngest daughter. So first school day, and so I need to get some family points because in this summer I was flying 5 weeks in a row. So it's difficult for me to get some more time. I mean, to travel around, and also we have plenty of work in the company. So anyway, so we are basically today I want to show you, the FES from a little bit more from the user point of view, and what options are available with the FES and so on. So in general, I'm working now for 13 years on the FES systems, and when I started, I was quite how to say, I would be lucky if I would be able to make like 100 FES systems, but so far we made 300 FES systems. So as I said, we started in 2009 with so when I cut the nose of my Lux 17A, most friends in my club, they thought that I'm crazy, but in these next 10 years we managed to start cooperation with most of the glider manufacturers. So and this is the specific numbers of the FES we made in since which year we start with which manufacturer and so on. Do you hear me well?
Yes.
Okay, so everything started like this. So my father was, he was building model, and I was looking. Anyway, when I was a bit older, he stopped. So I was just looking models on the shelves and so on, and eventually I started to build them by myself. I was building mostly free flight models, so-called, I think, Nordic gliders. So this is the oldest category of model building. So this is me and my father some years ago. This was, I think, with my Ventus in Pavulo. So he is also glider pilot and mechanical engineer. And he was experienced model builder when he was younger. So, and this is our team when we made the first 100 systems. So, so we have at the moment I have 7 people employed. So from sometimes we have also some students to help us with some simple jobs and so on. So anyway, it was necessary quite a lot of effort to make so that I came to the point that eventually I have my own Ventus 3, actually not mine, but factory owned. But this is how to say, this was my dream, and I managed to achieve it after 10 years approximately. So this is where I'm sitting at the moment in my office. So these are our offices where we need to do all the bureaucracy, design, and so on. So I'm sitting just at this table at the moment. So we have our own machines. We have 2 CNC machines. classical machines and so on. So at my father's company, who is producing the motors for us, he have also a few CNC machines, wire EDM and so on. So we are quite well equipped for the production of different molds, because actually this was actually my father's company. His main job is producing tools for plastic injection and the stamping tools. And I was also working at his company for 7 years when I learned to use these machines, CAD/CAM technologies, and so on. And I was a model builder from my childhood, so I knew how to use, how to work and with the resin, with the wood, with the metals, and basically I put together with my father's help, I put all this knowledge together to create the FES system. So this is in our workshop where we are doing the installations of the systems. So this is outside of our company. So here we were just doing, to put the glider on the scales for center of gravity. So eventually, this is how the fuselage is prepared for the engine installation, and this is how it looks when it's installed. But it's quite a lot of work in between, and a lot of steps or accurate task needs to be done, and checks and the balancing and so on. So when somebody see the engine in the front, sometimes people are checking, how the shaft is connected from the center of the fuselage and so on. But this view is better to understand how the complete front assembly is installed. So this is from Ventus front assembly. So the engine is just about 10 centimeter long, and is fixed on this so-called mounting plate, which is also suspended on the front rib with the rubbers, so that there is as little vibrations possible. And the thing is that we need to make practically everything ourselves. So the motor was developed by my father, and he is still producing the motors. So basically we're producing it together. So here the blades we produce ourselves, the spinners, all the wirings, we assemble battery packs, we make all the tests. So this is how the front assembly looks before is installed to the mounting plate in the glider. But of course, for the engine to run, we need to have very powerful battery packs. And 10 years ago, and even now, there was nothing suitable available on the market. So we developed this FES. This is Gen 2 battery packs. So this pair of packs goes into the glider. So with the customer, for each battery pack is standard equipment, this stainless steel transportation box to protect the batteries during transportation, because the main idea of the FES system was that you can charge the batteries at home, so or in the club house, because usually the gliders are how to say, parked in the middle of the airfield. It's difficult to get electricity there. Also, charging in the glider is sometimes not so easy, and and also due to the temperatures in winter is difficult, and so on. So this is the battery pack view from the top. So inside of the battery pack, we have so-called BMS, battery management system, which basically monitors and gives instructions to the charger, how to charge, when to stop charging, when to start, and so on. So it's basically we use so-called a bit, I would say, not stupid charger, but the charger is communicating with the BMS through this connector in the middle, and if the BMS recognizes that something is wrong, it would not allow the charger to start, or it would prevent charging if something would happen, and so on. So these are, for instance, 3 different chargers. So this smallest one is a 600 watt charger. This one on the top right is a 1.2 kilowatt middle power charger, and on the bottom is 2 kilowatt charger. So these more powerful chargers are optional, but a standard customer always get 2 600 watt chargers, so that battery packs can be charged simultaneously. It needs about 5 hours to charge fully discharged battery packs. But usually you don't discharge it completely, but let's say if it's discharged to 50%, then it needs about 2-3 hours to recharge the battery packs. We prefer these small chargers because, for instance, if you are on competition and there's poor grid, poor fuses, so then you are sure that the fuses will not go out, so that in the morning basically the batteries will be ready for flight. So with more powerful chargers, it's also important to have proper grid and fuses installed. So with each small charger and this middle power charger, it comes, these are so-called BMS charger cables. So the communication is done through this cable. So it goes to each battery pack. So here on the top right, this is similar charger like these two on the left, except that there is also a USB connector. So with this USB connector plugged into the computer is possible to monitoring charging with so-called BMS control software. So this is, for instance, how this BMS control looks. So on the first page, there is just settings, and you can see what is the charging current, charging voltage, minimum cell voltage, maximum cell voltage. You can see on the second page each cell voltage. So here, for instance, the difference is about 9 millivolts. So here during the charging, it calculates the internal resistance of each cells and so on. So for those who don't want to use the computer, I mean, it's not really necessary to monitor, but for instance, usually I don't monitor, I just connect, but I know exactly how it works. But for those who want to see, what is the state of charge and so on, we have also available such the optional equipment, so-called FES LCD display. And now we will prepare for the future also Wi-Fi module, so that you will be able to monitor this on a smartphone. So then, as an optional equipment, we provide this FES protection fabric for the propeller blades. If you use always a canopy cover in the trailer, then you don't need to use this. But if you don't use it, then it's really necessary to use these covers in order to prevent that when the fuselage is pulled out of the trailer, so that the blades would not open. So there are magnets which holds the fuselage, the blades are aligned against the fuselage, but if you pull the fuselage in and then you rotate slightly, it can happen that the motor will rotate a little bit and the magnets will not hold anymore. So it's good to use these covers in this case. But as I said, if you already have the canopy cover, then of course it's no problem to that the blades will open during the pulling the fuselage out of the trailer. So another optional equipment is this so-called FES bridge. This is simply a device which converts CAN bus signal to RS485, which is communication protocol between the LXNOW instruments and devices. So in this case, it's possible to have some phase parameters on the big screen of LXNOW flight computers, and at the same time, one advantage is that 6 phase parameters are written to IGC file. So if you don't see very well and maybe these small numbers on the FCU instrument are too small, then this is one of the possibilities to have bigger numbers, more visibility phase data. Okay, so as standard equipment, we also provide now so-called phase discharger. The thing is that the battery packs, they have its own aging. So they will get older and the internal resistance is increasing, of course, with time. But the problem is that it's increasing much faster if the battery packs are always fully charged. So for longer periods of non-flying, for instance, for 1-2 months, or let's say during the winter period, or even in summer, if you go to holidays with the family for 2-3 weeks, then it's good to discharge the battery packs to 50% state of charge, because it's safer and the internal resistance, so the aging of the battery pack will be slower. So basically you just connect how it works. You just connect these two cables, and then you press the button on this LCD screen, and it starts discharging. And when it's discharged to 50%, you just hear a beep, and then it's stopped discharging, and even if you left it connected, it will switch off completely after some time, so not to discharge further on. Okay, so these battery packs, this is how, this is a transparent view of the 3D model where the battery packs are located. So in most gliders, they are located just behind the rear tangential tube of the glider. So this compartment is very strong. It's behind, in case of accident, the battery packs are relatively heavy, so they could not harm the pilot and so on. And the center, it's also due to the center of gravity. The front assembly weighs the prop, the spinner, the engine completely about 10 kilos. And these battery packs, typical weight is about 32 kilograms. So it just offset the weight in the nose, so that the center of gravity of FES equipped glider is about the same like on the pure glider. So this is how it looks. This is, I think, in the Ventus battery compartment. So basically, all you need to put is to put the battery packs inside. Then you have these two struts with the knob, which holds the battery packs fixed in the battery compartment. Then you connect plus and minus power cables. Then this cable, black one with the connector, these are so-called data cables, so that the instrument gets the information about the battery pack's temperature and about each cell voltage. So before the flight, you put the so-called connecting cable, which is this U-shaped cable, so that both packs are eventually wired in serial. So people often ask if it's possible to fly just with one battery. So in our case, it's not possible, because we need, each pack has about a little bit less than 60 volts. And with this low voltage would be too high current required. Even for instance, if you want to have like 20 kilowatts of power. So, but when we wire them in serial, so this is about, so fully charged is 116 volts. So it means, it still needs like 200 amps to achieve 22 kilowatts. So, which is typically maximum power of the FES systems. For instance, now, some other manufacturers, they have higher voltage, but in our case, due to the fact that the battery packs are removable, I choose to basically stay at low voltage for the safety reasons. Also, the chargers are, so this is if the voltage would be higher, then I think would be quite difficult to make the battery packs safely removable. And also in case of servicing and so on, shipments are problematic if the battery pack have higher voltage. So this is, you can see here how the wires comes into the center part of the fuselage. So the plus goes over the high, about 300 amp fuse. So here on the minus pole, we have typically a shunt. So shunt is basically, device for measuring of the current in combination with this box on the left side. Below is the main contactor, pre-charge resistor. So this is typical arrangement in Champier gliders. So then apart from batteries and the motor, we also need a motor controller. This is a box which is typically located on the top of landing gear. So here is just controller, no wires, so I couldn't find a better picture. Here on left side there is a black box, and here comes the electronic with the circuit board where all the signal cables come together. And so the system is relatively simple, but still it's quite a lot of wires, and everything must be wired correctly to work. And then this is the instrument, so-called FCU, phase control unit, and it's of course on the instrument panel. So here on the right upper side, you can see how many kilowatts you are using. Then you have on the left side top RPM. Then you have temperature of the motor, temperature of controller. When power switch is not on, it's not visible. And then you have temperature of the battery packs, voltage, and amps. And this in the middle, these 10 bottles of battery packs, these represent remaining capacity of the battery packs. Here, right, of these bottles, it shows how much time you can still fly level with typically 4 kilowatts. On the top, 4 kilowatts of power. On top, we have a canopy warning in case that the canopy is opened. Below, we have indication of in millivolts what is the biggest difference between the highest and the lowest cell, and this is basically what we have here. So on the top right there is an instrument to switch on the instrument, and in general the instrument should be switched on all the time during flight, so that the temperature of the battery packs are monitored. So this is, this power switch, I don't know, I put it oriented differently, but here I don't know why it rotated me, the software. So basically to operate the phase system, we have so-called a power switch, which is usually on the instrument panel or a little bit below. It's a toggle switch with the red guard, so that you cannot switch it on unintentionally. So, and usually there's nearby like a sticker, on motor activated, off motor disabled. So if this power switch is off, you cannot start the engine. But when you want to start it, then it appears so-called this controller ready message, the green light, and here is indication of the voltage. And then when you get a green light and controller ready, then you can be like, pretty sure that the engine will start when you rotate this little knob below, so-called throttle knob. And you see here above is also visible temperature of controller. And above this, in the top, it's measurement of 12-volt power supply. And below is, like I already mentioned, the difference between the highest and the lowest cell. So these are, typical screen which you can expect, for instance, if somebody wants to start the FES system with open canopy, you get 2 warnings. First yellow warning, check canopy. Second warning, canopy still open. So anyway, third time it would allow you to start, in case that I mean, we don't want to rely on some switches, and this would prevent starting the engine. So this is canopy. These are 2 canopy warnings. Then, for instance, if you switch on the power switch and you forget to switch it off after some time, so if you switch it on and you don't start the engine, or you start the engine, then you stop it and then you still left it on, then you get this warning on the top right that power switch is on. So you basically press knob to dismiss, and of course then it's expected that you would eventually switch off the power switch. So then on the lower left side, this is another screen which you can check is a battery status. So it shows graphically representation of the lowest, first pack and the second pack, and it indicates what is the lowest cell. So in this case, 3.774 volts or 3,774 millivolts, and the lowest cell, and in the middle it's written the difference between the highest and the lowest cell. So this graphic presentation, it's important to know that it shows just relative values, not absolute differences. So this just the tops, I would say, of the differences. So 15 millivolts, it's it's small difference. Up to 150 millivolts, everything is okay. So then a yellow warning appears, and if it would be like 300 millivolts, then a red warning would appear. So here on the lower middle screen, this is a typical what you can expect during the engine operation. So here it's visible that the propeller is rotating with 3000 RPM, which is, and power consumption is 5.1 kilowatts. So voltage is 98 volts. So you can still use it for 25 minutes with this power. So you can see that 60% of power of the battery energy is still available. So 52 amps of current. So this is a typical screen during the level flight in a glider like Ventus or Discus, where typically 4 to 5 kilowatts of power is required for level flight at about 90, 95, maybe 100 kilometers per hour. So here is visible temperature of the motor 23 degrees, temperature of controller 20 degrees, and both batteries have 18 degrees. So to stop the engine, you just need to rotate the throttle knob counterclockwise, and then a message, then the prop stops, and after a few seconds you get message prop alignment, and when the prop is perfectly positioned horizontally, then you get the message, green message prop parked, and then the normal screen appears, and then you can switch off the power switch. So very simple operation of the system without losing any altitude during the starting, stopping, and so on. Okay, so here This is okay. This is so-called on previous screen. Maybe you recognize we made also a retractable system for 129 ASG29. So we add another icon on the top left, which shows the position of the pylon. So here on the top, you can see location of the power switch. So basically very similar system like FES, except that the engine is on pylon. So we have another switch on the top left for extension and retraction of the pylon, but otherwise it's quite similar logic like for the FES system. Okay, so this photo was also rotated on the left somehow. I don't know why. So it's not really visible. But on the right, you can see how we made. This is a battery compartment. Actually, this is what we modified is a standard ASG 29 turbo ready, and then we put the battery packs in the fuselage. So we did this already 2 years ago for a Lithuanian pilot, and he's quite happy with the system. So this year he won FCC competition. About 2 weeks ago, he won Livno qualifying Grand Prix and so on. So glider is still quite light, about the same weight like sustainer system, and it's even capable to self-launch without water ballast. So we could do more of this, but simply the paperwork and it's a little bit complicated. But we will see. Maybe in future we will also put a little bit of more effort to develop also a retractable system. But so far our tests show that, for instance, with the FES you need like 4 kilowatts of power for level flight, 4 to 5. With the race, you see on the top right, we made this is our logo. It's also similar like a race, just that the race letters are on top as a retractable system, and it's also a registered brand name, like our FES registered brand name. So anyway, bureaucracy is complicated. So that's and what I want to say, with FES 4 to 5 kilowatts for level flight, with race 7 to 8. So because the drag of a pylon have quite a big effect on the performance. So this is our duo discus. So recently we put some efforts to develop FES for double seaters, first with DG 1001 E as Electro. So the second one is was a duo discus, and we even made another two-seater to PV6, just a prototype. So the challenge with two-seaters is that we also need about 7 to 8 kilowatts of power for level flight, like because the glider is heavier, and so we made already the battery packs with similar construction, like standard battery packs for single seaters, but then unfortunately the cells which we were planning to use, they were not become available anymore, and so on. So it's a long story. Anyway, on the last half year or no, it's more than half year. It's about 1 year. We are working on new Gen 4 battery packs, which we intend to use for two-seaters. So these packs, so two such packs will go to DG 1001 or to Duo Discus, and it will be about 9 to 10 kilowatt hours of energy, so that we could eventually get similar performance range, especially in range like single seaters. So this on the bottom side, this is just the first half of this battery pack model. Finally, we managed to arrange so-called bonding, so connections of each cell, each cylindrical 18650 cells to bus bars. So you can see here we plan to use for double seaters 30 cells in parallel, so that we will have small enough internal resistance so that the temperature of the cells will not rise too much during operation. And this is how it will look, just the first assembly of the battery pack, still with the top cover still not anodized, so it will be anodized like we always do on the battery pack. So we expect to have such two handles, because the weight, I mean, if you want to have 10 kilowatts, then the weight of such pack will be about 24 to 27 kilos. It depends exactly on which configuration. So we will have two such handles. So the idea is that two people will carry the pack. So for one, it will be a little bit on heavy side, I think. So this is also one of the reasons I'm not with you today, because we are pretty busy with these new developments, and we need to provide we need to pass some EASA tests of thermal runaway, and we believe that with this new arrangement of the battery packs, it will be possible to pass the tests, because each every time EASA give us how to say, more demanding tests to pass. So, and this is quite a headache. Yes.
We are much left because we are running out of time, and Thilo Hollighouse is waiting behind us.
So actually, I'm just on the end. So basically, this was the last slide. So I just want to ask if somebody has some specific questions. So you can ask now, or you can send me email, and or I don't know. You can call me to my phone now, or we can talk via WhatsApp. So that's all from my side. What I wanted to tell you today. So thank you very much.
I think we have to connect Luka. So I think we thank you very much, Luka.
Okay.
Bye.
Bye.